Hello everyone, welcome back to Python and Pandas tutorial series. In this video, we will discuss Python operators. In Python, we have different operators for performing different types of operations, like arithmetic operators for doing math operations, and we have comparison operators to compare some values, and we do have logical operators for decision making and assignment operators for variable assignments and variable management. Similarly, we have membership operators and identity operators and bitwise operators, which we will discuss in some time in detail. Let us start with arithmetic operators. In Python, we have arithmetic operators which we use to perform some basic mathematical operations like addition, subtraction, multiplication, division, floor division, remainder, and finding exponential values. So we use plus symbol for doing the addition operation in mathematics. Similarly, the minus symbol for subtraction, asterisk symbol for multiplication, a slash symbol for division, and double slash when we want to find the floor division. So the difference between division and floor division is when you use single slash on two numbers like 7 slash 2, it will be returning a floating point number and the answer will be 3.5. But when you want the floor division of the operation, like 7 by 3 should be 3, not 3.5, you want to ignore the decimal values, then you have to use the floor division operator double slash. So 7 slash slash 2, it will be returning 3, not 3.5. And we do have a remainder operator whenever we want to find the remainder out of a division operation. For that, we will be using percentile symbol. And similarly, we have double asterisk operator, which is also called as exponent operator. So whenever you want to find some exponent value like 2 power 3, you can represent that as 2 star star 3. Let us see these in action by writing some simple Python. Open your Visual Studio Code and create a new file called Arithmetic Operators demo.py, and in that take two numbers for now like x equal to 9 and y equals to maybe 2. Let us see by using all the arithmetic operators we just learned. So if I want to know the sum of x and y, we should write x plus y. So we are using the addition operator over here. If you see the output, so instead of variables demo, we will be writing arithmetic operators demo.py. I didn't save this. So if you run this, we are seeing 9 plus 2 as 11. Similarly, if you want to know the difference of x and y, we can use the subtraction operator, which is minus, and for finding the product of two numbers, the multiplication operator star, and the division operator and the floor division, and the remainder operator is percentile, and the power operator is 1. So we are expecting 11 out of this 9 plus 2, and this should result in 7, and this should result in multiplication of x and y, which is 18, and this should result in floating point number. So 9 divided by 2 will be 4.5, and this is floor division, so we will get an integer which is 4, and the remainder will be, here the remainder will be 1 because 9 divided by 2, so it will go for 8, and will be left with 1 as remainder. And the power operator 9 star star 2 should result in 81. Let us see running this code and see we got x plus y, 9 plus 2 is 11 and 9 minus 2 is 7, and the product is 18. Normal division is 4.5 whereas floor division is 4, and the remainder is 1. Similarly, the power is 9 star star 2, which is x star star 2 is 81. This is how arithmetic operators works. And let us see another kind of operators supported by Python. Now let us see about comparison operators in Python. So when we have some requirement to perform some comparisons, we have different operators in Python which are going to return a boolean value based on the comparison result. So when we have to check the equality of two values, we have equals operator in Python, which is represented by equal to equal to. And when you want to check if two operands are not equal, you can go for not equal to operator, which is an exclamation followed by equal to symbol. And similarly, we have greater than operator and less than operator. Both are represented by right and left angular brackets. And we do have greater than or equal to and less than or equal to operators to check the value is greater than or equal to another value. So especially the comparison operators are useful when you are building some conditional statements, which we will be going to learn in further videos. So whenever we are writing some conditional statements, there might be some conditional statement and which is going to return either true or false, which is a boolean value that is to be used to perform some operation. Let us see an example of using all these comparison operators. Go to your Visual Studio and I will just comment out all this, or let us create a new file called comparison operators demo.py. And in this, if we have some variable called x and y equal to 10, and if you are using x equal to y, we will be getting true because it is going to check value of x and y. Got it? So I will discuss about few other operators in later videos where we check the memory location equality as well. And we have not equal to operator, and we can write like this to check whether x is greater than y and less than y, both are false, and greater than or equal to and less than or equal to. So let us try to understand or guess the output out of this. So x equal to x should return true because the values are equal, and this is false because the values are equal and the operator we used is not equal to. And x is not greater than y, it is equal to y, so it will return false. Similarly, x is not less than y because those two are equal, so it returns false. Because we are comparing with greater than or equal to as well, because x and y are equal, we will be getting 1 here. Similarly, 1 over here. And let us try running this, clear the output, and Python space arithmetic operators demo, not arithmetic operators, comparison operators. And if you see this, we got true for x equal to y, false for x not equal to, greater than and less than y, and true for the rest, like greater than or equal to and less than or equal to. So these are the comparator operators we have in Python. Now let us go to logical operators in Python. Python supports some logical operators which are used to combine conditional statements and make a decision based on the boolean values which are written out of that operation. So we have multiple conditional statements like the way we have written in earlier example. We have written x equal to y and x greater than y, like that. So we have multiple conditions and those are to be combined into a single decision making operation. In that case, we can use these logical operators to combine those multiple conditions or conditional statements. So in Python, we have three logical operators which are AND, OR, and NOT. So AND is used whenever you want to return true when all the conditions given in the operation are true. For example, if we have two conditions and you are using an operator on those two, so x and y, it is going to return true only when x is true and y is also true. Otherwise, we will be getting false. Example is true and false will be false. True and true will be true. False and false will be false. And we do have OR operator which returns true if at least one condition is true. So we will be getting true when x is true or y is true. So true or false will be true. False or true will be true. True or true will be true. And false or false, because both are false, there is no single true here, we will be getting false in the result. And not is just the negation. So if we have true, we will be getting false, and if we have false, then we will be getting true. So it reverses the result, returning the opposite boolean value. Let us see this with some example. Go to your Visual Studio Code and create a new file called logicaloperatorsdemo.py. Here we will take two variables, maybe one as true and false. In fact, we will not be taking variables like a and b. We will be going to do some operations in real time which will be going to return true or false. But for example sake, we are doing like this. So if we print a and b, because it is true and it is false, and returns true only when both conditions are true, it is going to return false. And if we print a or b, so or is going to return true if at least one is true, so the final result will be true. And if we try to negate any one of those, print and not a, so now we have true in a, so it will be going to print as false. So if we try running this by Python, or clear this first and Python space logicaloperators.py, you can see the output is matched with our expectations. So this is false and true, and this is how we are going to use logical operators. Let us see about another kind of operators which are supported by Python. Those are assignment operators. So assignment operators in Python are used to assign some values to variables. So whenever you have some value to be stored in a variable, we are going to use the basic assignment operator, which is equals. So which we already doing in our examples, like a equal to 10 or a equal to true, like that. So we are using a single equal to symbol to make some assignment, and that single equal to is actually called as basic assignment operator. And apart from this basic assignment operator, Python also provides some other operators which are termed as compound assignment operators. These operators actually combines the actual assignment with some arithmetic or bitwise operations. Bitwise operations we have not seen yet, but we already know the arithmetic operation, so we can take some example out of that. So compound assignment operators are like, if you see the table here, plus equal to, which is compounded, the assignment is compounded with an addition operator as well. So plus equal to, which is written as a plus equal to 2, and which is nothing but a equal to a plus 2. So we are doing some addition here. We are adding up 2 to a and reassigning the value to a itself. In that case, we can use a equal to a plus 2. And similarly, we can use any of the arithmetic operators we have seen earlier, like a minus equal to something, a star equal to something, like that. Based on the operation you have to combine with, you need to combine with the assignment. So let us see this in some example. Go to your Visual Studio and create a new file, assignment operators demo. In that, let us see the basic assignment which we are already using in our examples. But just to repeat that here again, x equal to 10. And this is to assign some number into a variable. And we do have something called y, and we are going to save a string in that. So y equal to Raja. And if we have some complex types, not simple value, or if you have collection of values which we will be discussing in later parts, maybe we have z equal to 1 comma 2 comma 3, which is a collection of elements. Got it? So we have three variables here, and we used basic assignment operators equal to assign some value into the variables, right? So if we try to print all these, print x and y and print z, y and print z. So if you clear the output and try to run the assignment operators demo.py, you see the values which are actually assigned to the variables are printed. This is what actually we already learned. And now let us see some example for the compound assignment operators. Let us take, like, we already have 10 in x. Now I want to increment 10 by 5. So I want to add 5 to 10. So either we can write x equal to 10 plus 5, or I want to increment the value of x. So I will be using the value of x plus 5. So this is the actual way we need to do, and this can be shorthanded like x plus equal to 5. So this is the assignment operator, which is going to combine the assignment as well as the addition also. And if you see printing x now, you will see 15 at the end. Sorry, I'm sorry, we already assigned x equal to x plus y. Here the value of x became 15, and here it will be going to add one more 5, and the result will be 20, and hence we got 20 in the output. And similarly, if I want to reduce this by 10 again, x minus equal to 10 can be written. So here we have a compound operator minus equal to, which is going to do the subtraction and assignment. And if you print x now, you will see x value will be reduced by 10 and the output will be 10 again. See, this is the 10. And similarly, you can use x star something. So x equal to or x star equal to 2, and the output will be 20 over here, and the result will be 20 over here because here we have 10. And now x slash equal to 2. So in this case, what it is going to do is 20 divided by 2, x equal to x by 2, x equal to 20 by 2. In this case, it will be 10 again. And if I want to floor division, so x slash equal to, because we have 10, let us try with 3 now. So in output, we should see 3 because 10 by 3 is 3.333 like that, and we will be taking only integer. So let us see printing x now, and in output I should see 3 now. If you clear the output and run this again, 3.0, so we have 3 in the output. Similarly, we have power as well, and we can use the compound operator along with the bitwise operators also, but we will see the bitwise operators first before discussing that, right? So this is about compound operators we have in our compound assignment operators and basic assignment operators, which are termed as assignment operators combined. Python has one more kind of operators which is called as identity operators. In this we have two operators like is and is not. So identity operators are actually used to compare the memory locations of two objects, we can say. So there are two things, and we are going to compare the memory locations instead of the values. So they check whether two variables refer to the same object in the memory or not, instead of just comparing the values which are stored in that variables. So we have two identity operators which are is and is not. Is actually returns true if both variables are referring to the same object in the memory. If we have two objects A and B, and if we are writing as A is B, then it is going to return true if A and B are referring to the same object in the memory. And is not, it is going to return true if the variables refer to the different objects in the memory, right? So it is just reverse of is. So is A is not B is going to return true when A is not referring to the same object as B. Let us see some example. Go to your Visual Studio Code, create a new file, identity operators demo.py, and take two lists x equal to 1, 2, 3, and take another list y with same values, and take one more list and add one more element into that and name this as z. Right now we see the values in these two lists are same, 1 2 3 1 2 3. So if we use equality operator over here, which is double equal to x equal to y, it is going to check the values if you remember. So if you run this, you should see true. So Python space identity operators demo, because it is checking for the values, but these are two different lists which are saved in different locations, or these are considered as two different objects. And if you try to use is operator over here, so x is y, then because those two are not same objects, I mean those are not referring to the same object in memory, it is going to return false. See, this is false over here. So it is actually checking the values inside the list, and here it is referring the memory location of that, or if they are referring to the same object or not. Let us see print x is z or x is not z also. We don't need z in fact, but we already have that and we are checking that output. So these two are not same. So we will get true in the output, this one. And similarly, even if you use the equals operator on x and z, see, you will be seeing false for this because these two are not having same values, right? But whenever you are using is, there are some things to keep in mind, like whenever you have some value, integer value you can say especially, and the integer is a smaller integer like maybe 0 to 256 we say. So these are termed as small integers and these are cached by Python. And even these two are saved in different variables. So now we have two different variables. And obviously a equal to b is going to return true. But see what happens if we use a is b, it is still going to return true only. I will comment out this. If you clear this output and run this, so we still got true even these two are different variables, because even we are creating a new variable, because it is small integer, Python actually caches that value and the new variable will also be referred to the same location in the memory. That is why it happened, and it will not happen with the larger integers. And the similar thing will happen with the strings also. Some smaller strings will be cached and you will be seeing true even if you are saving the same value in two different variables. So that is one of the thing you need to keep in mind. So this is about identity operators in Python. Now let us see about one more thing called membership operators in Python. In this we have two operators, in and not in. So why we use this and what are these means? Membership operators are used to check if a value or object exists in a sequence, like it may be a list or tuple or sets, dictionaries or strings. All these we will be going to discuss in further videos, but for now let us consider a list which we have already seen in the earlier example. And if we want to check some value exists or some element exists in the list or not, or in some tuple or not, in some set or not, in that case we can use these membership operators, so that based on the existence we will be getting either true or false. So if we are using in operator, and if the given element exists in the given list, then it is going to true, else it is going to false. And similarly not in works in opposite way. Let us see this with example, and let us create a new file called membership operators demo.py. And here let us take, maybe instead of taking integer array, we were taking integer list till now. So I will take some string array, maybe cities or fruits, and in that I am going to save some strings like apple and banana and maybe cherry. So now we have three elements in this list, and I want to see if banana is in fruits or not. I can write a print statement asking print if banana in my list, which is fruits. If you run this, clear this and Python space membership operators demo.py, you see it returned true because banana is a member of fruits list. And you try to write another print statement, and here you are trying to see if grape exists in fruits, And because we don't have grape in fruits list, it should return false. See, we got false. And similarly, if you write this as instead of grape in fruits, grape not in fruits, because it does not exist in fruits, it is going to return true here. This is how we will be using the membership operators. And you can use this membership operator with the strings also. Like, for example, if you have a text or maybe message equals to like the hello world program we have written, right? So hello world or hello welcome to Python. So we have this string maybe, right? And I just want to check if something like some word or some sequence of characters are there in the string or not, right? So we can use like this, like print the required word is maybe welcome, okay, in message. So it is going to return true because welcome is there in the string message. If you run this again, you will see true at the end. See? So this is one of the usage of in and not in also. If you want to check if the given word is not there in the string, then also you can use not in. Strings are also sequences, so in works with the strings. So if you want to see some key differences between these two operators like identity operators and membership operators, this table helps you. So we have two kinds of operators in Python. One is identity operators like is and is not, and membership operators are in and not in. The main purpose of using identity operators is to check if two variables refer to the same memory location, and membership operators, they are actually checking the existence of the given element or value in a sequence. And comparison type, so it compares the identity operators actually compares the memory locations or memory addresses. Instead, membership operators actually compares the values in the sequences and will return true or false based on the existence or non-existence. And identity operators, any objects like numbers, strings, lists, tuples, etc. Membership operators can be used on any sequence like list, tuples, and remember strings are also sequences. That's why we are able to use the in operator or not in operator on strings and dictionaries as well. And both are going to return a boolean value, whereas identity operators returns a boolean value which is true or false based on the object identity, and membership operators are going to return true or false based on the value is present in the given sequence or not. And example is a is b, a is not b. Here if you see, there is a variable called message. In that we have Python, so we need to check Python in message like that. So this is the comparison between identity and membership operators. And now let us see the last type of operators we have are bitwise operators in Python. So Python supports some bitwise operators. So bitwise operators actually perform some operations bit by bit on numbers. So if we are performing some bitwise operation on two variables or two numbers, it is not going to work on the number directly, but instead it is going to represent the number as a binary formatted number, and it takes all the bits out of that number and it compare each and every bit. For example 5 can be written as 0101 in the binary format and 3 is 0011. So whenever you are comparing 5 and 3, it is not going to compare 5 and 3 directly, but instead it is going to compare ones, 01, 1000 like that. Okay, so let us see the table which is shown here. So we have the different kind of bitwise operators: and, or, XOR, not, and shifting left. So left shift, right shift. And is actually called bitwise and it returns 1. So it is going to return bits instead of true or false. Now the symbol we use for bitwise and is ampersand symbol, and it returns 1 if both bits that are being compared are 1. Otherwise it will return 0. And bitwise OR, sorry, we don't have example over here. And the symbol we use is pipe symbol. I need to make a correction over here. And bitwise OR, it is going to return 1 if at least one bit is 1. So if we are mentioning 1 or 0, it is going to return 1. Let us see this in example, which will be easier. So let us open Visual Studio and create a new file, bitwise operators demo.py. And let us take two numbers, a equal to 5 and b equal to 3. And remember what a will be represented as. It will be represented as 0 1 and 0 1, whereas b will be represented as 0 0 1 1. And if you print a and b, so we are using ampersand symbol, which is bitwise, and clear the output and python space bitwise operators demo dot py. So we got output as 1 because it is going to compare 0 1 0 1 to 0 0 1 1. And let us see how this actually works. It is going to compare 0 and 0 because it will be ampersand will be going to return 1 only when both values are 1. So because we have both zeros, the output will be 0 1 0, so both are not 1, so 0 0 1 is 0, both are 1 in the end, so it will be 1. And whenever you are writing this in the base 2 format, it will be 2 power 0, and then if it is 1 again, it will be 2 power 1, it will be 2 power 2, it will be 2 power 3 when it is 1. Now we have only 1 at the end, so it will be 2 power 1 at the end, sorry, 2 power 0 at the end, which is 1. So the output should be 1, and we got 1 over here. Got it? This is how bitwise operators work. And now let us see another example of using bitwise OR as well. So A by P. And if you see, discussed like a bitwise OR is going to return 1 if at least one bit is 1. So the output of these two, the comparison between these two will result in 0 0. So it is 0, 1 0. So we have at least 1. So it will be 1. 0 1, at least 1 we have 1, both ones, so at least 1, so the final result will be 1. Now it is 2 power 0. I will do that from right. So 2 power 0, and it will be added to 2 power 1 and add it to 2 power 2. So it will be kind of 2 power 0, which is 1, plus 2 power 1, which is 2, 2 power 2, which is 4. So the output should be 4 plus 2 plus 1, which is 7. So if you run this, see, we got 7 over here. And similarly, we have XOR operator, which is actually called or represented by a cap symbol. Right. So it actually, what it does is it returns 1 if both bits are different. Otherwise, it returns 0. So let us see print A cap B. So it will be, so now XOR returns 1 if the bits are different. Otherwise, it is going to return 0 only. See, these two are same. So 0 and 0. So hence these two are not different. It is going to return 0. And we have 1 0. So these two are different, hence we will get 1. And 0 and 1 are different, hence we will get 1. And 1 1 are same, hence we will get 0. So now it will be converted to 2 power 0. It will not be considered because this is 0. So it will be 2 power 1 plus power 2. So it will be 2 power 1 is 2 plus 2 power 2 is 4. The output should be 6. Let us see. We got 6. So this is how we use the bitwise operators based on the requirement. We have not, left shift, right shift. So not is actually used. It will flip the zeros. Sorry, it will flip the bits. from 0 to 1 and 1 to 0. And you need to remember here, even it is flipping, Python uses 2's complement for negative numbers, so the output might be little different. So you can practice with multiple examples by referring online. And left shift and right shift are there. Those actually shifts the bits in the actual given value either to the left or to the right. And simply saying, whenever you are using left shift, it actually multiplies the actual number by 2 for each shift. So whenever you are writing a left shift 1 means, and if you have 5 in a, it multiplies 5 by 2 one time. If you left shift a left shift 2, then a will be multiplied by 2 two times. So 5 will be multiplied by 2, which will be 10, and it will be multiplied by 2 again, which will be 20. And similarly, right shift actually divides by 2 for each shift. Got it? So this is what bitwise operators we have in Python. So with this, we are done with operators in Python, and in next video we will discuss about how to take some user input and how to print the values to the console. Thank you for watching, and please don't forget to like and subscribe.